Thank you very much for the kind introduction and for inviting me to present some of my most recent work on artificial intelligence. Today's talk is about a success story of how Spotify is using artificial intelligence to improve the way people consume music. And this is specifically joint work that I did with colleagues at New York University and also with the research and development group at Spotify. So for those of you who are not familiar with Spotify, it is this huge music streaming platform that has more than 500 million users. Okay? This screenshot over here is essentially the desktop application that they use in order to recommend some of their playlists. And the interesting thing here is how prominently these playlist recommendations are being recommended, because each and every one of these playlists is custom made for the user. And so, for example, if we focus here on Discover Weekly, this playlist over here actually changes from user to user because it always considers only songs that the user has never listened to before, but that Spotify believes they would enjoy. Then we have here a bunch of other playlists called the daily mixes. Again, these are playlists that are tailor-made because they only consist of songs that the user has listened to before and that Spotify thinks they would enjoy if they were to recommend that right now. And the thing here is that these playlists were not built by any specific user. They were generated by Spotify. Then we have more specific themes for these playlists. So if the user is feeling good, for example, then they can get a playlist that specifically tailors songs for that mood. If they want to avoid distractions, they can get the Focus Now playlist specifically, again, tailored to the user. And so the big challenge here is that building this playlist is hard because preferences vary a lot from user to user, right? And so if we have something like the Happy Saturday playlist, what we want out of this playlist could be completely different from one person to another. Maybe you are the kind of person that really enjoys rock music, right? And so you only want rock songs in this Happy Saturday playlist. Maybe you're somebody like in this screenshot over here, somebody from Greece, and so you only listen to Greek music, right? And so if it's Happy Saturday, you only want songs that are from Greek bands, okay? And so Spotify needs to build these systems that are capable of creating this tailor-made playlist for each and every user. And so how do they do that? It's essentially summarized in this picture over here. What Spotify does is that it has this special kind of playlist that they're going to be calling algorithmic playlists. And each of these playlists has an underlying theme. And so in this case, the theme could be Happy Saturday. And so Spotify hires a bunch of different human experts to curate a pool of songs that is related to this theme. And so in this case, for Happy Saturday, we may have thousands of cheerful songs that humans are picking up because they believe it's going to be like a good match for Happy Saturday. And then Spotify is going to deploy this data-driven system that I will be calling the algorithmic DJ, okay? That is going to compare each and every one of these songs with the listening history of the user, right? And so this system, if it finds that the user has been listening a lot to pop music, it's going to say, oh, probably the cheerful songs that I should pick should be in the pop genre, right? And so I start to rank all these songs according to their similarity to the user preference, and then pick the top K, and that would be the custom-made Happy Saturday playlist for this user. Of course, there are multiple ways in which you could say that music is similar or dissimilar to each other, right? Like lots of different methods that we could use to rank these songs. And in fact, Spotify devotes a huge amount of effort and time. The research and development team that I was working with spends a huge amount of time just trying to come up with new ways to compare songs. Basically say, to what extent are these songs matching or not the user preferences? But the problem is that if you just look at the playlists that are being generated by these DJs, you simply cannot tell which is better, right? Like, should we really have Queen at the bottom in the existing DJ case, or should we have it at the top? You know, like, who is to say whether this is a better way to create a playlist or not? And so the question for this talk is essentially, how do we choose which algorithmic DJ to use? And a popular answer for this question in this age of digital experimentation is to use A/B testing. And so for those of you who are not familiar with A/B testing, it is a very simple but powerful data-driven methodology that a lot of platforms are using to choose between two or more alternatives. Okay? And so in the case of A/B testing, I'm going to explain it with a brief example over here. Imagine that you have two different versions of a website. So I'm going to say variation A, which is green, and variation B, which is blue. And what we're going to do with A/B testing is that all the incoming traffic of users is going to be randomly assigned to one of these two alternatives. Okay? And so in this example, we get 50% of users seeing version A of the website, and the other 50% are going to see version B, right? And then we need to collect data on what is the user behavior under each of these variations. And in the context of companies, we are typically interested in maximizing certain business outcomes. And we're going to call that a conversion. And so, for example, in the context of Spotify, a conversion could be more paid subscriptions, or people are saving these playlists to their libraries, or they're sharing this stuff in social media, right? But honestly, a conversion could be whatever the business is interested in maximizing. And if you care about more than one thing, you could just do some sort of weighted average about these things. And that's how you could optimize for it. And so if Spotify were to choose between the existing DJ and the new DJ, what they could do is run an A/B test and just pick whatever seems to be working best from the point of view of the business. But this is where things get interesting. Maybe it is the case that one specific DJ works better for certain type of people. Maybe DJ A works very well for US users. And maybe DJ B works very well for Japanese users. And in fact, this is something that happens quite often in Spotify. Because it turns out that most of their users are from the US and Europe. And so they have lots of data for that. They don't have as much data for Japanese users. And these algorithmic DJs have different data requirements. So it could be the case that if you have lots and lots of data, then DJ A works very well. But once you deploy it to a place where you don't have as much data, then that DJ doesn't work that well. So you would have to go with something simpler. May work very well in Japan, but it's so simple it wouldn't work that well in US, right? And so we're seeing this for countries, but this could apply for many other things. Maybe people enjoy sequencing differently based on whether they have a free subscription and they need to listen to ads, or a paid subscription where you don't get the ads interruptions, right? And so that could play a role. It could be the case that how long is this user with Spotify? Do we have a lot of data about this user and we can build good playlists, or not as much data? Is this a playlist that has to do with a mood or a task, or is this something like Discover Weekly, which is just bring me whatever thing is new about this, right? And so all these different factors play a role, and that's pretty much the problem that the research and development team raised when I reached out to them. Right? How do we go about this? And the proposal that we had as a research team was to use machine learning to predict for every and single user what is the best DJ for them. So based on the user characteristics, can we predict what DJ should we give them, right? And so if you don't have a background in machine learning or AI, fear not, because I'm going to give you the intuition of how it works. So we want to build a magic crystal ball. And I'm going to call that magic crystal ball the artificial intelligence system, or the AI system for short. And what this magic crystal ball does is that it transforms data into some sort of prediction. Okay? And so in this case, data could be something like the country where this user is from, whether they're paying or not for premium, how old they are. We have data on all these things, but there's some quantities that are unknown. And in this case, we do not know if this person will convert or not if exposed to a specific DJ. Right? And so what we want this AI system to do is to take that data and transform it into some sort of prediction of whether this DJ is going to work or not. And so the follow-up question is, how do we build this system? And the answer is machine learning. So machine learning is a methodology that we can use to automatically extract patterns from historical data. In this case, we want to find some relationship between those user attributes, the things that we're using to predict, and the stuff we're predicting, which in this case is converting or not. And so I can collect a bunch of data of how people react to this DJ. And once I collect the data, I can use my machine learning algorithm to find any pattern or relationship between these user attributes and whether people are converting or not. And all of this is done automatically. That's like why it's considered AI. It's essentially a program that can write a system, right? And this learned model, this resulting pattern, is what we would incorporate in our AI system to transform data into predictions. And so if we jump back to the original question, which algorithmic DJ should we use? The answer is whatever works best. And so if we have this user from Colombia, not paying subscription right now, 26 years old, we have two quantities that we do not know. We do not know how likely this person to convert with the new DJ, and we do not know how likely they're to convert with the existing DJ. But if we could predict that, then we could just choose whichever system works best for this person. And so there are many different ways in which you can use machine learning to predict this. And so part of our research was to consider all these different algorithms and try to classify them into these three general types, okay? And so the most simple and straightforward, or at least the most well-known, would be the outcome learner. This category of algorithm essentially is going to try to predict two quantities separately. It's going to try to predict conversion for the new system and conversion for the existing system, and then you can just pick whichever works best. But we could get more specific. So we could try to learn an effect, right? I'm going to call this the effect learner. And essentially, we're going to consider the two quantities simultaneously when we're learning from the data. And so I'm interested in learning whether things are going to improve or go worse, right? And so I'm learning this difference. And essentially, if the difference is positive, it means I should go with a new DJ for this user. And if the difference is negative, it means I should go with the existing one. But we could get even more specific. Maybe what we care about is not really learning the magnitude of the improvement, but learning if there is going to be an improvement or not. So rather than predicting the difference, I could just predict this inequality. Is the new system going to perform better or not? And so if you just take a look at this picture, you may think, well, all of these things look the same. There's a key distinction here, and it's in their level of generality. If you go with the assignment learner, it's going to be able to predict what thing is better, but it's not going to help us to predict how much better. If you want to predict how much better, you need to be a little bit more general. So you need to go to the effect learner. And if you want to predict exactly how many conversions am I going to get out of this, then you need to go even more general, and you need to go to the outcome learner. And the key insight here is that there is no free lunch, okay? Like, if you want to go very general, you're going to have worse performance for the most specific task. And so if the goal of the system is to just choose which digit to deploy, you're probably going to be better off with the assignment learner. And that's what I'm going to be showing you in a couple of slides. But first, I want to remove myself from all this abstract talk and go back to Spotify's problem. So this is pretty much the setup in which we compared all these different AI systems, right? We had this huge A/B test where we considered 770 million playlist requests. And essentially, each of these requests was randomized into 4 different systems that could be used for generating playlists. These are the algorithmic DJs. So 85% of the incoming traffic was assigned to the system currently in production. And at the time, the research and development team was considering 3 other alternatives, right? Which is like I represented here as orange, blue, and green, right? So each of these alternatives is getting 5% of the incoming traffic at random, and we collect all this huge data. So with this data, we give it as an input to the machine learning procedure, and we're considering 3 types of algorithms here. So it's the outcome learner, the effect learner, and the assignment learner. And each of these learners would get a different AI system, right? And we want to understand which of these AI systems work better, right? Which approach of learning would work better. And to refresh a little bit what the AI system is doing here, the AI system takes in a new playlist request. This request is going to come with some information about the user, like their country, their age, whether they're paying subscription or not, right? And you compare, the AI system compares this user in a sense with everybody else that it has seen in the A/B test. And it may discover that persons from Colombia, 26 years old, they are not paying a subscription, green is better. And so out of the 4 DJs, it would say, oh, for this kind of user, it seems that the green DJ would work best. And that's how it starts assigning different DJs for different people. So these are the results. And in the context of what I'm showing you today, conversion is how much more music people are listening thanks to these DJs, okay? And so the y-axis would be, to what extent can we increase the number of songs that people are listening? And in the x-axis is the amount of data that we're using to learn these systems. The 3 lines at the top would consist of the different machine learning algorithms, right? The different AI approaches. And the red thing at the bottom would be just a standard A/B test. Like, forget about the AI stuff, just run a standard A/B testing. And perhaps the most dramatic finding here is how much things can improve if you go from just a standard A/B testing to actually using AI to choose what DJ to deploy, right? In fact, the first time that we saw this is just crazy because the A/B testing doesn't seem to be doing anything at all. And the reason why that happens is because each of these DJs work equally well on average. If you were to deploy any of them on average, they're kind of the same. But when you start to look at subgroups of people, maybe DJ A works better for Japanese, and DJ B works better for the US, and these for free, and these for premium, right? And so when you look at very specific populations, that's when you start to see differences in performance between DJs. And that's what AI is capturing, that standard A/B test that just looks at the average wouldn't be able to capture. The second thing that is interesting here is how dramatically performance can increase with more data, right? You can see that as you give more and more data to the AI system, it works much better. But in the case of A/B testing, it doesn't make much of a difference because really you're just calculating an average. So if you're interested in an average, it doesn't make that much of a difference. But if you're making individual level predictions, then getting more data is actually much more useful. And finally, we go back to this point of general versus specific. If you recall, we have this assignment learner is just predicting what thing is better. It cannot tell you how much better, just what is better. And if you focus on the specific task of just choosing what is best, then it turns out that being specific about your task makes a difference. In this case, we're talking about a 1% increase in streams. That scale of Spotify, we're talking about millions of minutes more that people are spending in the platform. And so if you have to take away anything from this talk, it's pretty much these 3 things. First, AI is going to allow you to extract you more value from A/B test data. So this is not really an argument of not doing A/B test. You need to do A/B test. And the reason why you need to do that is because you're collecting data. And so you run the A/B test, collect the data, and feed it so that you can build these AI systems. Second thing, the data size is going to matter a lot in respect of the performance that these systems can achieve, as long as you're using AI for this. And finally, you should think carefully about the tasks you're trying to solve with these algorithms. If it's only about choosing systems, that would require a different learner than if you want to measure the impact of these systems. And so thank you very much for your attention. I hope you found this thought-provoking and look forward to your questions. Thank you very much.
Thank you very much, Carlos. Any questions from the audience here? Yes.
Thanks for sharing. That's a really interesting topic. Is the standard A/B testing conducted on the total population of users of Spotify?
Yes. So here, these A/B tests of 770 million requests was on the entirety of the population of users.
So
yes.
I wonder what will be the improvements if we conduct A/B test in subgroups.
So that's a good question. So the idea is that if you want to know which subgroups are going to benefit from this, at the very beginning, you don't know. And so what you do is that you collect data on the entirety of the population so that later on, the AI system is going to tell you, oh, for these subgroups, it seems to be making a difference. And so once you know for which subgroups it's making a difference, then you focus your experimentation on those groups. And so the answer is you would like to do that tailor-made A/B testing after you have gathered data on the entirety of the population so that you know where to focus, and that's what they're doing. So in those countries where they know, oh, it seems to make a difference here, then they do more exploration there so they can get more data for those specific components. Yes.
OK, thank you. Can you show the takeaway slide?
Yeah.
I noticed that for the effect learner, there is a steep increase after the users, the data from 350. So is there any intuition from why this
There is an intuition. It's a little bit subtle, but I will try to communicate it as best as I can. So in a sense, right, like these algorithms are teasing out correlations. And so you want to find a correlation between the whatever you're predicting and the thing that should work best. And so it turns out that just predicting who is likely to convert is actually a very good proxy for saying how good something is. And so that signal, in the case of the blue, is more highly correlated with choosing something than the effect itself. It's subtle because the problem is that, essentially, if I had to summarize it, the signal for the orange line is smaller than the signal for the blue thing. But if you keep gathering more and more data, eventually orange should perform better. But the signal is so weak that unless you get a lot of data, you're not going to see it. Yeah.
Okay, thank you.
No problem.
Okay, any other questions from the audience here? Yes, over here.
Thanks. So I have a question. So in the machine learning process, how do you design the mechanics to avoid the recommendation bias? Thank you.
So good. So this is slightly different from traditional recommendation system because this is not really learning what content to recommend, it's learning what DJ to launch, right? And so before we conducted the A/B test, people could not self-select into DJs because the DJs have never been deployed, right? And so you don't have this bias in this case because people cannot decide, oh, I really want to listen to this DJ. In traditional recommender systems, people can self-select into content, right? So because they can self-select into content, then you need to account for that. In this case, because you're starting from scratch, collecting the data from zero, then you would not suffer from that bias just because people cannot choose the DJs on their own. Yeah. Good.
Okay, other questions? And also for those of you who are on Zoom, if you have a question, feel free to raise it or just type it. Carlos, maybe I'll just ask one clarification question. I'm thinking about the usage scenario of your research. Am I right to say that this finding that you have and the methodology that you are proposing here will apply better when the training, the machine learning, would end up with multiple models, and each of them may work better in selected context. And as a result, it is very difficult for the decision maker to settle on which one of them should they choose. And then your method is kind of like a second layer decision algorithm to help them pick which one of them to use.
Yeah, so like for these things to work, there must be what they call like in academic terms, heterogeneity, right? Like there must be difference in preferences. If there is one choice, one DJ that is clearly superior to all others, then this is worthless because it means that everybody would be better off. But it is when you have this diversity in preference that the method really shines. And so in the case of Spotify, right, like the motivation is that the way in which you should sequence or select these songs is so different from user to user, then it would be really hard for a human to know, oh, I should really pick this DJ, right? So it's an automated decision making where decisions could vary drastically. But if you're making levels at a more higher level, right, or where there's not as many options or where there is not such variation in preferences, then this wouldn't work as well, right? And so you, as you pointed out, like you would have to find the right context for these findings to apply.
But that's kind of interesting in the sense that if you look at what the companies are doing these days, right? Very often the companies hire data scientists. And then all of these are trained in machine learning. And the standard way you do this is, you build a couple of competing models, and then you go through a cross-validation, you do many rounds of assessment, and you always end up with one model better than the other based on whatever data that you are using. So I'm wondering, in what circumstances would we end up in a scenario when the company is really indecisive between multiple models? Because the data scientist would always come up with a conclusion, this model is better than another.
But I think data science has actually shown that the combination of models is better because it's the motivation for ensembles, right? And so in a sense, this is creating an ensembles of DJs. That's it. It's just an AI system to create an ensemble of DJs. And so to the extent, right, like a company that is interested in creating this ensemble of models, could deploy this kind of thing. So it is not always the case that maybe one model is better than the other on average. But very often is the case that for certain type of the decisions, one model does make better decisions than the others. That's why we do ensembles. And so I think that this would work very well, especially in cases where you have different requirements of data. So for example, as I mentioned, at Spotify, for certain regions, you simply don't have as much data. And so maybe something simple like naive Bayes would work very well. But if you go to the US, you have lots of data, and so you use the neural network. And so maybe you can use this approach to understand, based on my data requirements, for example, whether I should deploy one model versus the other.
Okay. Thank you. Very interesting.
Thank you
Any
very much.
other questions? If not, maybe we will now move on to the next sharing session, and afterwards we can have an overall Q&A again. Thank you very much, Carlos.
Thank
you
you
again.